Welcome to another Lazy Shell tutorial video. Today we're going to pick up where we left off with animations and talk about the commands that you can use in animations. First off, there's a minor error in this program you should know about. You'll notice that this line here will always reference whatever command is selected on the left. Even if we choose a different command from this drop-down menu, it still shows this text from this command here on the left. It's not that big of a deal, it's just a visual bug, but it is something to be aware of so that you don't lose track of what you're doing. If you select a command from the drop-down menu, enter in the information, and click Apply Changes, it will still work as it's supposed to. But the first command, let's talk about it. New object, sprite equals x at coordinates amem32. If this looks like a foreign language to you, you're in good company. I didn't understand a lot of this at first, but let's break this down. AMEM stands for Animation Memory. There is a separate command which we'll talk about next, which stores coordinate data to amem32. This command creates a new sprite at the coordinates stored at amem32. You can choose whatever sprite you want, as well as what sequence you want it to use. Sprites and their sequences are found in the Sprites editor. Priority determines if the sprite is behind or in front of different layers of the battlefield. If it's behind the battlefield, you won't be able to see it. Generally, you'll always see 3 used. This makes the sprite show up on top of everything else. VRAM stands for Video Random Access Memory. Basically, when you load in a new sprite, you need to give it a place in memory to store it. You need to specify what address in memory, and you'll want to use an address starting at 6200 up through about 7800 and in increments of 200, like 6200, 6400, 6600, and so on. There are technical reasons for that, which I won't get into, but suffice it to say that this is what works. For just about every ally and enemy, including specials, you'll see sprites loaded using VRAM 6200, 6400, and 6600 most commonly. For some of the battle events, like when Yaridovich clones himself, or when the smelter pours that molten liquid that Smithy turns into a shyster, you'll see addresses in the 7000s used. Palette row number. This is another one that's a bit technical, so I'll give you the simple version. When you load up a sprite's palette, or colors, similar to the VRAM thing, you sometimes need to give it a place to stay. That's what this does for you. The Super Nintendo can only keep track of so many colors at a time, so this says, I want you to keep track of this color for now. You know those bluish stars that appear when you hit an enemy? Those stars are their own sprite that gets loaded into memory, and it has its own palette. If you didn't give the hammer palette a separate place to stay in memory, the game would try to overwrite the hammer's palette when it loads up the star's palette. The result is that Mario's hammer would take on the same bluish hues as the stars, even though the hammer is still on screen. Overwrite VRAM. This tells the game to forget whatever it had stored at this VRAM address previously to make room for this new command. You'll see this box checked just about every time this command is used. Looping on. When you load up a sprite, you also load up an animation sequence. With this checked, the animation will loop forever until something tells it to do otherwise. Box 3. This is another parameter of some kind that you can give to a sprite. However, it's unknown what this does. The fact that it is unknown should tell you that checking or unchecking this box probably won't make a difference. If it does make a difference, you might be the first one to discover what this box does, and if you do, please tell us. Overwrite palette. This tells the game to overwrite whatever palette is in memory with the palette of this new sprite. If you leave this unchecked, the new sprite will take on the palette of whatever was in there previously. Mirror. Flips the appearance of the sprite. If the sequence loaded in normally has the sprite facing left, checking this box will make it face right, and vice versa. Invert. Similar to mirror, checking this box will flip the sprite upside down. Behind all sprites. If part of the new sprite overlaps with part of any other sprites on screen, the new sprite will appear behind the other sprites. If you didn't have this checked, Mario's hammer, for example, would appear on top of Mario instead of vice versa, so the handle of the hammer would sort of awkwardly be floating on top of Mario's arm. Overlap all sprites. This allows the new sprite to overlap with existing sprites. Next command, amem32 equals coordinates xyz. You'll often see this command somewhere before that new object command we just went through. This lets you choose a location on screen to store at amem32. There are other commands that tell a sprite to appear at these coordinates, or tell an existing sprite to move to these coordinates. The origin is the starting point. You can choose whether you want the coordinates to be based on where the user currently is, where the user stands on the battlefield when they're not using an attack or special, their target's position, or absolute position, which lets you choose the coordinates on the screen independent of where any other sprite is. From here, you can edit the coordinates relative to the origin. These amounts are measured in pixels. They can also be positive or negative. For example, entering 50 in the x-coordinate is 50 pixels right of the origin. Negative 50 is 50 pixels left of the origin. You can also choose which one of these coordinates you want this information to apply. For example, if you just wanted a sprite to shoot across the screen horizontally, you would only need to choose the Set X coordinate option. Next, sprite equals x, coordinates amem32. This is like a watered down version of that new object command we went through. Just like that other command, you choose the sprite, you choose the sequence you want it to use, but you only have to specify a few other things. Store to VRAM. You choose this if you need to set aside a space in memory for the sprite. Theoretically, you wouldn't need to load it into memory if it was already in memory somehow, but in practice, you'll almost always see this box checked. Looping on. Just like before, it makes whatever sequence the sprite has loop indefinitely. Store palette. Again, just like before, this tells the game to store the new sprite's palette to memory. Without this checked, the sprite will use whatever palette was in there before. Next, pause script until. Just like it says, you can use this to pause the animation script using a few different criteria. Resume after sprite shift complete. The game will wait until the current sprite has finished with its sequence before it moves on with the rest of the script. Beware, if your new sprite command has looping on checked, then the sequence will never end and the animation script will soft lock the game. Wait until button press. The game will wait until the player presses a button. Number of frames elapsed. And then from there you can choose the number of frames below. This frames box only does something if you choose the number of frames option. The game runs at 60 frames per second, so a 60 frame pause would be 1 second. But normal lag and system performance means the exact translation from this command to actual time may vary. Next, remove object. Simplest one yet, but also very important. It removes the currently referenced sprite. If you don't remove a sprite when you're done with it, it'll just stay on screen. If you have too many objects on screen, it can crash the game. Return object queue. You may have noticed these object queues. We'll talk about these more when we get to them, but this command is necessary to put at the end of an object queue so that the game knows that it's done with that particular block of commands. For the next command, let's take a look at super jump. Move object speed equals x. As the name implies, this tells a sprite to move and how fast to move. Speed. I'm not sure what speed is measured in. I've seen values all over the place. You can see Super Jump has Mario moving at a speed of 193. Generally speaking, the higher the number, the faster the movement. Although the upper limit is over 32,000, I've found that you stop noticing a difference once you go past a few hundred. Positions. Again, I don't know what these are measured in, but you moved toward the end position relative to the start position. As you can see, you can use both positive and negative numbers. Down here, you can choose which properties you want to apply. Mario's super jump just goes up and down vertically, so the z-axis is the only axis affected here. If you don't select these other three boxes at the bottom, the command won't work right because it doesn't know how fast it'll go or where it's supposed to be going. For the next command, let's look at a monster spell. Jump to address. This tells the animation to jump to a different location in the code. Remember from the previous video that each address within a dropdown begins with the same first two digits, so we only care about entering the last four digits. You'll see this command used a lot for repeated lines of code. For example, you'll see this group of commands that resets some memory-related information and removes the current object in just about every spell. Rather than entering the same group of commands over and over again, you can enter it once and then just jump to it whenever you need it to save on space. Pause script for one frame. It does exactly that. You'll sometimes see this command used as filler in the animation. The game puts this command here if there is no other command at that address. As mentioned before, you can't simply add or delete commands in this editor. You can only rearrange what is already there. What this means is that if you want to add in a command, you have to clear some space to make room for it. amem40 equals coordinates x, y, z. This works exactly the same as the other one we talked about earlier. The only difference is this stores the coordinate data at amem40 instead of amem32. Move sprites to coordinates amem40. It makes sense that you'd see this one right after the one we just saw. This moves the sprite to the coordinates stored at amem40. There are two types of movements: shifts and transfers. Shifts will move the object such that you can actually see it, well, moving. Transfers will essentially teleport the object to those coordinates so you don't see the movement in between. You can choose the speed of the shift. Again, I don't know what this is measured in, but it seems to use the same speed parameters as the previous move object command we talked about. You can also choose if you want the object to move with an upward arch. Yet again, I don't know what this is measured in, but for frame of reference, the attack that Dry Bones uses, where it throws a bone at you, uses an arch height of 96. Reset target mapping memory. There are different commands to store targets to memory, keep them in memory, or release them when a command is done, etc. This command just makes sure that any previous information stored about targets is reset. That way, the commands that are about to be issued regarding targets are not affected by any previous targeting information. Reset object mapping memory. This is the same idea as resetting the target memory, just with the various sprites. Jump to subroutine X. Like I said before, to save time and memory space, for groups of commands that are used multiple times, it makes more sense to write it out once and then just tell the code to go look at that batch that has already been written. The key difference between jumping to a subroutine versus jumping to a different address altogether is that when using a subroutine, you can use the return subroutine command, which takes you right back to where you left off in the code. For example, right here, returning the subroutine tells the game that it's done with this subroutine. Go back to the place in the code where you first told me to go to this subroutine, and continue looking at the next line of code as normal. Whereas with using the jump to address command, using a return command doesn't take you back to where that jump to address command was. This can be complicated to understand, and we're starting to get into computer programming class territory, so I'll just leave it at that for now. Return subroutine, we just talked about. It's how the game knows the subroutine is done. Visibility on and off. A nice break from the complicated commands. These commands make the current sprite visible or invisible. Next, you'll see a big block of various commands related to a mem. Memory is useful for many different things. They're especially useful in what we call conditional statements. Basically, these are commands that say, if a certain condition has been fulfilled, do a certain thing. So that'll look like part of an animation sequence saying, once a certain amount of time has passed, set a certain memory to 1. And then another part of the animation sequence that'll say, pause the script until that memory is equal to 1. They're used in timing attacks. If the player times an attack, set a certain memory. Skip the second half of the attack if that memory isn't set. They're used in super jump. There are memory bits that keep track of how many jumps you've done to force you to stop at 100. There's a separate memory bit that keeps track of the highest number of super jumps you've done so that you can get the attack scarf and the super suit. They're used in jump to keep track of how many times you've used it because it gets more powerful over time. It's used in items. Using items stores a random number between 0 and 100 to memory. If that memory value is over a certain threshold, depending on the item, you get a freebie. What's more, the item's index number is also stored to memory. If the freebie occurs, there's a command to store whatever item is at that index number to your inventory. You can use memory for all of these different things. All of these commands let you do things like set memory to certain values, clear the values, jump to a different address if memory is or isn't a certain value, or is greater than or less than a certain value. You can have one memory bit increased or decreased by the amount stored in another memory bit. One word of caution. Some memory bits are more permanent than others, and you should be careful about changing them. Like I said, there's memory that keeps track of how many times you've used jump. You don't want to accidentally overwrite that by using that same memory address somewhere else. Moving on from these amem commands, we get to attack timer begins. This has to do with the flow of attacks and items themselves. To put this in very simple terms, this command tells the game to wait for everything within the animation to finish before ending it. If you don't have this command at the end of certain animations, they won't look right. For example, if you don't have this command at the end of Group Hug, this spell will still heal you, but the healing numbers don't have time to show up, and it ends quicker than it usually does, and it just doesn't look right. Pause script until memory bits set or clear. We talked about memory and how to utilize this already. Sprite sequence equals. We talked about sprite sequences earlier when we talked about new objects and sprites. This lets you change the sprite's sequence after it has already been summoned on screen. You can also turn looping on or off, or you can mirror it. This B6 box is another unknown property. Again, if you figure out what this does, let us know. amem60 equals current target. This stores whoever the current attack is targeting to amem60. You'll often see this used in tandem with commands that create a new object at memory 60. Say, for example, if you attacked an enemy with a bomb, you could use this to generate an explosion sprite right on the target. Pause script until sequence is done. This will tell the game to stop reading through the commands until the sprite's current sequence is done. If target is alive or disabled, jump to address. Just like it says, you can tell the game to jump to a different command's address depending on if the target is alive or dead. Sprite queue, offset sprite equals. This command is used in battle events. Let's take a look at the battle event where you beat Croco for the first time and Mallow punches him. You generally use these commands when you have a series of commands that you want to give to a sprite that is already present. This is a very tricky command to use for multiple reasons. One, you'll notice this object number here at the top. This requires you to know what sprite number Mallow has in this fight. Besides looking at this code that already exists, you would have no way of knowing that sprite number other than guessing until you got it right. Another issue is this address here. You need to have empty space at this address to insert the commands. This requires you to free up some space. But once you have that worked out, you would insert whatever commands relate to that sprite. Here you can see kind of the layout of that scene. Mallow is transferred to these coordinates, which are right in front of Croco. He puts on his angry face, yells at him, then he punches him. Next, we have return sprite queue. You need this at the end of the sprite queue command we just talked about. Display message at OMEM60. Let's take a look at a command which uses this. You'll see this used for animations that display a name before they're used, which is basically just enemy spells. You'll also see a command before it setting OMEM60 to memory address 072C, which is the name of the current attack. Notice that these two commands here are very similar, so I'm going to talk about both at the same time. These are similar to the sprite queue offset command we just talked about with Mallow punching Croco and such. Once again, these kind of require you to already know what address you're looking for and what index you're using. There's no way to know what index has commands under it without looking at the commands that already exist in different animations. OMEM60 equals 072C. We already talked about this. This is used in tandem with the display message command to display the name of the current attack. AMEM equals random number between 0 and x. These are some more AMEM related commands, which we already talked about. The difference between these two commands is that the upper limit for the first one is 255. The upper limit for the second one is 65,535. Overlap all makes the current object appear on top of everything. Overlap none makes the current object appear behind everything. Now this is a good place to stop. We'll stop here for this video. We'll cover the rest of the commands in another video. As we touched on in the animations intro video, this is one of the more technical editors in Lazy Shell. If this seems overwhelming to you, you're not alone. I would encourage you to start small. Change small things one at a time so you can get a feel for what they do. Don't try to make a brand new animation from scratch. Again, we'll cover the rest of these commands in a second video. If you want to support the channel, if you like what you see here and you want to make sure to catch these videos as they're released, please consider subscribing to the channel and throwing a like my way. It really does help. Thanks, and we'll see you next time.